Hello, so we are going to be going over oral exam 2. Okay, so for question 1, I asked why it's an improper integral. So we see that this is a type number 2 improper integral, and why? Because f is continuous on the closed integral a to b except at c and a to b, then the integral of a to b f of x dx equals to the integral a to c f of x dx plus the integral c to b f of x dx. So we're going to plug in this for this formula here, and we're going to change these bounds to 0 to 1 and 1 to 2. And because 1 is in between 0 to 2, right, f is not defined here at 1, because we can see this by plugging in 1 into x. So we have 1 over 1 minus 1 squared, so then you'll just get 1 over 0, and you cannot have the 0 in the denominator. It does not exist here. It's not defined, so this is why this is a type 2 improper integral. Okay, so now number 2 asks for why is the integral of 0 to 2 f of x convergent or divergent. So note that if it's convergent, the limit exists, otherwise it is called divergent. So we're going to have this formula right here. The integral of a to b f of x dx equals to the limit of t to b to the left, the integral of a to t f of x dx. So we're going to be working with this integral here. So we have the integral of 0 to 1, and we're going to plug in our f of x, which is 1 over x minus 1 squared, and then dx. And then we're going to take this limit from 1 to the left, and then we're going to substitute this 1 for t. And here we see how to solve, how should we solve for this integral right here. We're going to be doing a simple u substitution by substituting u for x minus 1, and then its du is 1 dx or dx. And since we did u substitution, we're going to change our bounds, and to do that we're going to plug in these bounds into x. So t minus 1, our upper, and 0 minus negative 1, 0 minus 1 is just negative 1 for our lower. And so we will plug in 0 for x minus 1, so we'll have this 1 over u squared, and then we're just going to rewrite it, and then we're going to have to plug in our new bounds here. And once we work through this a bit and plug in our new bounds, we end up seeing that the limit of t to the 1 to the left will be negative 1 over 1 minus 1, which goes to infinity, minus 1 still infinity. And since this does not exist, it is divergent. And for number 3, find that the integral of 2 to infinity, if this is convergent or divergent. So we're going to be using this following formula right here. And so after plugging everything in, we're going to substitute in our t for our infinity. And then same thing up here, we're going to do a simple u substitution for x minus 1. We're going to put in that u. And then its du is dx. We're going to change the bounds. So this would be t minus 1. And for 2 minus 1, it's just positive 1. So this will be the limit of t goes to infinity, taking the integral of 1 t minus 1. And then we have 1 over u squared, right, because we substitute our u in for x minus 1. And then we're going to write this through, rewrite it through, and then you have to take our new bounds that we solved for right here. And after working that through, we see that the limit of t that goes to infinity, negative 1 over infinity minus 1. This graph goes to 0, and so 0 plus 1 is just 1. And since this number exists, it is convergent.